Welcome to Chemistry in the Air. Acid-base equilibrium. Now, acid-base reactions, Bronsted-Lowry described are equilibrium reactions. There's just a few strong acid reactions that don't operate. The proton, when transferred from acid to base, can be transferred back in the reverse reaction. Substances formed when the proton is transferred are termed conjugate acids and bases. So what I want you to copy out is the colors. Conjugate acid, chemical species formed, the reactant base accepts a proton. Conjugate base is the chemical species formed when the reactant acid donates a proton. So accept and donate. Might have been distracted and said it backwards, but it's written correctly. The reason why I use the term chemical species is because sometimes it's an ion, sometimes it's an actual non-charged acid or base compound, okay? So species covers all. And, well, I'll pause the video so you can copy this down. So, first example, I'll say the base is hydroxide. Typically, though, you'd never have just hydroxide. You could have sodium hydroxide, potassium hydroxide. But it's the hydroxide. Right away, you should think that's a base. Now, copy that out, and I'll talk to you why conjugate acid is wrong. So, remind us what we wrote down. Conjugate acid is the species formed when the reactant base accepts a proton. If this is our base, hydroxide, I add an H plus, that's a proton, right? Hydrogen. Add H plus to OH negative. You got two H's, and there's no charge, positive and negative. O as its conjugate. Now, just thinking of this here. And I mentioned this before. I'm just writing this here, and I'm going to talk about H plus being added. If I bring that in, I like thinking about water in the acid-base unit as HOH. You can write it as H2O, but I'll often write it as HOH as well. And it just makes more sense because you can see the attachments: hydrogen ion, proton, and the hydroxide, HOH. So I often will write water as HOH. Vice versa, by the way. I worked backwards. I have water, and I'm going to call it HOH. And when the acid donates a proton, so if that front H disappeared, we'll go right back to hydroxide if it's lost, because that's the job of an acid, to give away a proton from H plus, and you would form the base. So this is the idea of equilibrium. It goes back, forward. Now, another example like that. If I said the acid is H2SO4, sulfuric acid. Now with acids, we generally take off one H at a time. So if I remove one group of H plus from this, it's gone. But anyways, we're going to be left with H1HSO4. But you remove the positive. So that's why you have to have a negative sign in the conjugate base. The acid's job is to donate. Get some practice. Let's jot these two down. Okay, let's start with an actual reaction. We have a base and an acid adding to each other. Jot this down, and I'm going to remove the blue box there. We'll see what's ended up, but we're going to be able to predict this. Okay? I'll give you a moment to jot that down. And actually put in a double arrow. double arrow is an equilibrium reaction. Okay. I labeled which is the base, which is the acid. You wouldn't be able to tell necessarily without me telling you. So if it's ambiguous, I'll let you know. The job of the base is to accept an H. The job of the acid is to donate it. So if you think of water, and I'm going to rewrite it above here. If you think of water as HOH, and you donate one of the H plus, I think of it as the front H plus. So what I'm thinking is that H plus is taken from water and it cruises over and is added onto there. Okay, so you're going to be down. You're going to have OH and H left. But then you're going to have two H's, CO3. The positive hydrogen will add the positive to the negative by carbonate ions. They'll add up to 0. So the way we're going to show this is there. H2CO3, hydroxide ion. Label those the carbon. Conjugate acid, carbonic acid. Conjugate base. So if you read that from right to left, it creates the other things. Okay. So we're going to try one of these from scratch. Predict the products, label the acids and bases. I'll do this with you. I'll let you jot it down first. Okay, I'll start with, in this case, it isn't so ambiguous, which is the acid and the base. If you think of an acid as something that must donate H+, the only thing that could be an acid is the hydrochloric acid. This must be the base. Okay. Already said it's the job of the acid to give away an H+. So if HF loses H and a positive charge, losing H is easy, it's just F. What about losing the positive charge? From 0 to negative. Yeah. The base's job is to gain that H. Always put the H at the front, unless there's, there's very few exceptions, unless it's considered an organic acid, CHCO. But you'll see it, acetic acid. Anyways, so we're going to put that H plus at the start. It's only plus 1 though when you're adding it to 2 minus. So it's going to be HSO3, but 2 minus and plus 1. We'll only have one negative. Two ways to think about which is the conjugate. I'm going to talk to you about, if I read this backwards, if I'm reading this and I'm going from right to left, what happens to the F here? Here, it picks up an H. That's the job of a base, right? A base means, okay. So what we're going to label this is, because it is linked, is the conjugate. Base. The other way of thinking of that is HF, the acid, turned into F minus, fluoride. So that acid always turns into its conjugate base. Likewise, if I read this right to left, HSO3 does what an acid should do. It donates an H plus to there, right? So reading it right to left, it acts as an acid. So I'm going to say it's the conjugate. Acid. know what you're meaning, if you write down just C, B, C, conjugate acid. You don't have to write out the full words. I have it written out this time. After this, okay? Now, I'm going to give you guys some practice sheets. I'll pause the video. So we all have this worksheet. I'll talk to you about the first batch of questions. Now, list the conjugate acids for the following. These are bases. What's the job of a base? To get or to gain or to lose an H plus, to donate or accept. To accept or gain an H plus. Now, I don't care which one. Choose one of these. Of the first five. Now I'll do it with. Okay. NO3 minus is the base. That's nature. So if this gains an H, we're going to put it on the front, and it'll become HNO3. What happens to the charge? Positive to a negative, 0. So I'm going to see if I've got them in the right order. Oh, that's now, this arrow is only as a label. This is not a reaction, okay? Just put the H plus onto each one of those other four ones, okay? The conjugate bases for the following. So this one here. So the job, or the conjugate bases for the following acids. An acid will get rid of an H plus, don't it? Each one of those will go down. Which one should I do out of that list of 5? Sulfuric acid, H2SO4. We only lose one of the H's here. Okay? So just one of them is gone. So the HSO4, what happens to the charge? Subtract positive 1. So there we go. Right? Okay. Now, the word amphoteric we talked about before. It could be an acid or a base. You're going to look above after you do all of those and see there's some things that could act as, that seem to act as an acid and a base. Ambidextrous, left or right, amphoteric, acid or base. I'll let you guys work with me. Okay, so take these up. OH, if it's acting as a base, it picks up it becomes water. HOH is great to write down. Picks up an H, CO3 2 minus, H, CO3 2 minus. I'm just offsetting them so it's not all squished. HCO3, H2, CO3. Likewise, HCl. Okay, and HP, 4, 2 minus, 3 minus. Now when you lose the H, and lose the charge. H2O, 3 plus, or H3O plus. Yes. Good health wish to you and all of. That's not special. God bless you. Okay, so do we get this idea? Okay, now I asked a question here. Which of the following listed above could be amphoteric? Could be an acid, could be a base, depending on the scenario. Now, you notice that, okay, all of these are broadside bases, so that means what I have written in blue here are acids, right? Now, we've seen this before, and likewise here. These are all bases. Water can act as an acid or a base. We see it, right? If you look on here, is there anything else like that that's in the list of either both as an acid or as a base, or within these categories? Is there anything acting as an acid and a base in two different scenarios. Water, I already mentioned, yes, definitely water. Which one? Did I hear CO3? Here it is as base, but here it is as a base. CO2 could, because it can't donate an H. But that's connected to HCO3, acts as an acid or a base depending on the scenario, and I'll coach you on that. So HCO3. Oh, science appreciates. So, that being said, some of these things you don't actually see direct evidence for, but you can maybe think, maybe in a scenario it has space to pick up an H plus and be a base, or it could give away its H plus and be an acid. Is there anything when you scan this? Okay, we had HCO3. Why could this be a base or an acid? Because it has an H plus, so you give it away. That's an acid. Or it also has the space with the negative sign. You can easily see, oh yeah, it can definitely accept an H plus and become H2. Now, when you look at some of these other things, it's not likely that HNO3 is going to pick up another H plus. It doesn't have a negative behind it, so it probably is introduction. However, something like HSO4, that could give up an H plus, an SO4 too. That'd be an acid. Or it could be a base because it can pick up an H, become H2SO4. Just read that right now. You guys follow that? HPO4 right here. 2 minus. That one. No. That could do it. H2PO4 could also be an acid or a base. So which of those? Now you have direct evidence of a few, but there's some that you can. You see evidence of the first three right on there, but then you can extend that to think, oh yeah, also these other ones. Some things are amphoteric, can be acid or base. We'll take a look at some full reactions. Okay, this is where you only see a few things. So here's an example. If I give you the full reaction, right? How do I know this is a base? Because I look from here to there, it picked up an H plus. That's the job of the base. And that, therefore, it must be the conjugate acid. See on the other side, right? HCl is an acid, and it gives away its H plus. When we look down in here, first one, I want you to put in double arrows. Typing that number that's so looking at B, that isn't done. From left to right, what does H2PO4 do? PO4 negative. It loses an H, and losing an H or donating an H is an acid. Okay, so that's an acid, therefore it must be a base. And then you say conjugate base, conjugate acid. Okay, so that's those questions. I'll let you finish those, and I'll just talk to you about the other thing. Okay. There's one done for you, but I'll just erase it. We'll figure out how to do it. Okay, I have A written out, but we're going to just do some predictions. Now, these ones I made it obvious which one's the acid because it has an H to donate. NH4 positive. That has to be the acid because it has an H to donate. Cl minus does not. So this has to be the base. If NH4 plus is the acid, this is a weird one because the H doesn't come at the start. We take off an H plus, so we lose the positive. And we lose one of the H's, and you're down to 3. We'll call it ammonia. It's NH3. It gave the H to the Cl negative. Put that generally on the front when it's instructed to do those. It's Cl, and that's hydrochloric acid. And it does. The H plus makes the negative 1 of Cl minus 0. So I'm putting Cb and Ca, conjugate phase conjugate. Okay? So you're going to list the left side and then come up with the products on the right side and label those conjugates. Yes?
And when we're talking about acid
I don't really, just acid and base on the left side. You could say Bronsted acid base. Don't worry about BB. AB. And that takes you to the end. Finish these up. One last thing. All of these reactions, I didn't type them out with double arrows. They should be. Okay?